Welcome to IoT Coffee Talk.
Hey, that's just the
Welcome.
All right.
Yeah, you know, the reason why I played blues is because I got the Moderna shot, the second one, and it beat my butt up.
Hey, by the way, where is this guy that I call the Anthony Bourdain of IoT, the bad boy?
You mean Rob?
Hey, you got it. Okay.
Yeah.
He's the Anthony Bourdain of IoT.
Yeah, he is, and also kind of like the wine aficionado dude as well, right? But yeah, welcome. So we have AGK and we have PG. This week, it's all about acronyms, and in this episode of IoT Coffee Talk, we're going to be talking about casual. No, I'm just kidding. You know, I always read it as casual for some reason. I don't know why, but no, causal digital twins, right? Yeah. Which is just an amazingly intriguing concept. And we have who I think is a guru at this joining us to have a IoT Coffee Talk about it. So why don't you guys introduce yourselves?
I'll go first.
Yeah.
I'll tell you briefly why is causality so important, and we'll take this up.
Okay.
This causality is the single most important connection in the universe, and I'll substantiate this, during our back and forth.
Okay.
My name is PG. What qualifies me to do this is it's going to be a slightly long introduction. About 20 years ago, I developed a full-fledged industrial-strength IoT system for Rockwell automation, and I've been doing this ever since. And 3 years ago, my job at NEC in Japan was going to their 6 global labs. They have labs like MSR, Heidelberg, Tokyo, Beijing, Singapore, Princeton, and Silicon Valley, and pick out these technology gems and put them through a startup accelerator internally. So one of them that I picked up was on causality. So for about 3 years, I knew about this. So it has been spun out. It is called inguo.com, .io, INGUO. But my understanding was limited. I was just making the gates that they pass through, are they qualified? But in the last few months, got very seriously interested because I think IoT is, we need causality to cross the chasm that I can talk about later.
Okay, wonderful. AGK, you want to introduce yourself, or are you going to hide?
You know what? I'll hide if that's okay with you, because I think I was not prepared for this. I thought I was going to be a listener, so I'll be a listener.
Really? Nobody's ever prepared for this. Yeah, Oh,
interesting.
No, we're not even prepared for this. So are you prepared for this, Marc? Are you ever prepared? No, we're never prepared. Yeah, come on. Join the conversation. We want to see your face.
And at any time, any of my girls can pop up here and scream something. So I'm not prepared for anything.
Yeah, we're not. But
I need a digital twin and a causality to predict them.
He got it.
Yeah. So help us understand. So I read through this deck that you sent out, learning causal digital twin. And help us understand what's the difference between a correlation and causation, because that seems to be two distinctions that you emphasize and describe through the piece. So
if you could let me show a slide, that would help a lot.
Okay.
Because I don't think there is a better way to demonstrate the difference between correlation and causation than this little picture. I'm still not allowed to share, I think.
Oh, okay. Hold on. All right. Now you can.
Okay, thank you. This is a very simple picture, but it gets the story told. I don't know whether you can see on the bottom right-hand corner. Do you see a little truck?
Yep.
That's it. Look at the guy who's in the truck bed. He's pushing. And if you're just looking at correlation, yeah, his push and the truck moving are correlated. Right? But look at the guy in the back. He's pushing too. He's also correlated with the movement. But if you had to, they're tired, it's hot, you want to give them an energy drink, who would you give it to so that you get the truck moving? The guy in the back, right?
Right.
So this is just a simple way of thinking about it, but there are 2-3 different ways of thinking about another simple way. So let's say we have 2 things that we are interested in. Correlation is a single relationship between them. And in fact, there is no directionality. It is 2 things are correlated. One correlated with the other or the other correlated with this doesn't make sense. It is there. But think of the causality between those 2. It is suddenly a lot more complicated. This one can cause this, that's a directed arrow. Or this one can cause this, that's a directed arrow. Or they can cause each other. Suddenly, correlation, which was a single relationship, now causation, there are 3. So everything gets more correlated, more complex. Now, for the practical way, the real difficulty comes in the following. So if you don't have causality, you cannot develop explanations. You can only say, when this happens, that may happen with that much probability. That is prediction. That is correlation-based prediction.
Right.
But this is what we've been seeing in the last, so many years, explainable ML. Right?
Yeah.
People are annoyed, beyond just being told, go do this. They want explanation. They want reasoning. They want what is causing what, perhaps a chain of causes, what is doing it. So for doing that, it becomes pretty obvious that you need to know how these elements are causally connected. And in the terminology of causality, what we call is correlation can do predictions, but causation can help you do predictions and explanations. And explanations require causality. There is no way around it. So when I think about it, and as an IoT, lover, ecosystem champion, all those things, and you may be seeing a slide saying kink in the IoT growth. Are you seeing that?
Yeah.
Okay. So I've been involved, like I said, for 20 years, and I've seen the first part of the curve and actually done it and implemented it. And it's been very helpful. Seeing what's going on with remote machinery and stuff really helps you form an opinion about what's going on, but it only gets you to a certain level. And I'm afraid, I don't know whether you all share the same feeling, that there's a bit of disillusionment. What is all this nice dashboards and this doing to my bottom line or top line? Yeah. I spend hundreds of millions of dollars deploying this across my huge factory or factories. Yeah. This is nice, but nice is not enough for the CFO of your customer, right?
Yeah.
So what is lacking, in my personal opinion, it is what is called prescriptive analytics. That is what these explanations tell you. Right?
Yeah.
If this thing happens, that happens. So if you can do some experiments on it, then you can say, there is something we can do with this. So instead of talking a lot about it, I just made up a thought experiment. This is not real. I'm not a car guy. So I said, what can you do with causal digital twin for EV, for example. One classic use case is, and of course, one of the things primarily for EV is driving range, right?
Yeah.
So instead of just seeing what is the tire pressure on your dashboard or the remaining battery in your dashboard, that's all great. Can we do something better? We can if we have these causal relationships available to it. So I just made up an experiment. We have not done it.
Yeah.
I want a partner to do this POC, and I'm ready to give away everything to go and do this. But this may settle things clearly in our heads. So let's say we have these sensors. A is a current draw sensor, temperature sensor. B is some RPM and torque sensor on the motor here, and something on the tire to see how things are going. So one of the first things in a causal analysis is you talk to this, EV expert, auto, genius, and he or she can tell you, well, there is a simple, what we call a DAG, directed acyclic graph we can draw. Because if the outcome variable is A1, that is the current draw, we want to know what the current draw is. It is affected by, as you can imagine, RPM, torque, all those things, right? So this may be the graph that explains or its causal basis of what the current draw is. Now, if that is the case, and there are some technical things to be done to make sure that, say, C, that's the RPM, the tire RPM, does have a causal impact on current draw. Maybe this link doesn't exist. So there are technical ways to know which links exist out of this fully connected one and which are the directions. And in IoT applications, I usually punt that issue because that is very difficult. It's called causal discovery. So the reason I punt it is, in man-made systems, as opposed to, let us say, in some healthcare study, you smoke, you're obese, you have diabetes, and then you die. If you say, what is the cause? It is hellishly difficult. They're all connected to each other. There is no expert who can come and say, oh, this is why it happened. It's not clear, right?
Right.
Cases from point to case, it varies, and population it varies, and so on. But in our realm, we made it as man-made systems. We engineered the system. So when the design went in, we knew what was going to cause what. So the domain expert can give at least a very good starting point without doing the technical causal discovery. By the way, the startup I spun out of NEC, that's what they do. Without domain expert, given data from these 5 nodes, it's a huge search. It's we were thinking of using quantum computers. NEC has those things, supercomputers, because number of nodes increase. You can imagine the search is enormous.
Yeah, but aren't the economics just a bit out? If you're tapping or looking to tap into quantum computers to do this, which I think have at the moment limited capability to do so in a economic way, isn't this a bit ahead of the curve?
Well, that's the reason why I stayed out of what Ingo's market is. So their market is like market research. Like one of our clients was China Mobile. So they go do this big survey and say, okay, their outcome variable is customer satisfaction, let us say.
Yeah.
So then they had this big questionnaire. We sent it to like 1 million people. We got 100,000 responses. So it is like download speed, the monthly, subscription amount, customer support, blah, blah, blah. So there is like 50, columns or parameters, and outcome is satisfaction. Now, within this, what is causing what is what China Mobile wants to do so that it can adjust it. Now, here are smart guys, without having done the analysis, can you imagine what was the biggest causative factor in customer satisfaction?
So let's quality of service.
Yeah, quality of service, download speed, all that stuff. At least in China, maybe this is same everywhere.
Yeah.
It was simply the monthly subscription fees was the
Oh,
biggest causative factor.
right,
But
right.
but it's good to know. Otherwise, you may give them a gigabit pipe and nobody gives a rat's ass, right? So
Yeah,
to speak.
yeah, yeah.
So that's a very difficult thing. That's why I keep staying on this IoT domain. So, Leonard, like I said, this is man-made. So somebody can give me this graph. I don't have to go discover. So causal discovery, then comes causal estimation. But the estimation is from the data, find out what is the amount of this causality. This is it zero or is it 0.1? Is it one? And then on this graph, if we change it, how does the outcome variable change? For example, what is B2, RPM? So, in these EVs, there is no gearbox, right? So there is an RPM versus torque adjustment. You need more RPM to generate more torque, etc. Right? So they have a setup there. So it can be tuned. So if you tune that, would that reduce, increase current draw? Of course, we have to see how does that satisfy the driving feel. Do you still get the oomph out of it, etc. So it's amazing. You can use it for all those things. From the current draw, it's just the basic is like predictive monitoring kind of thing, performance monitoring. There'll be a new thing on your dashboard. It'll look something like this, and it'll show as the car is running, some causation, some link gets, let's say, thicker or brighter, and it goes this thing. It'll be a cool kind of this thing, dashboard, but also it'll be indicative of fault prediction. Suddenly, one link just got very strong, got red, hot. You may take it to the dealership. You may want to. But the real value is in the last two. This is not all one, just 2 and 3. So these two is really where causality makes the difference. You can do what if analysis is obvious, right? If we did something, what will happen without having to go and do it on the car. So we don't want to do destructive stuff. But on this graph, you can do all of those things. You can change the torque RPM relationship and see what happens. Is the current draw uniform, minimum, etc. Right. So that is what if analysis. Again, my understanding is limited, so I can't think of a lot of what if analysis, but an expert will have hundreds of things. So one little thing I use is, if you're thinking, where do I use causality in IoT? This is the answer. Just think about where you have a why question. Whenever you want to answer why, you need to know causality. Without causality, you cannot answer why. So if you say, why is this running hot? Then you go to causality. You find, current draw is higher. So the temperature of the battery is going higher. So whenever you ask a why, so if it is in utility or electric distribution, there is a brownout, and you say, why is there a brownout? Then you need causality. You need the graph. You need to be able to do this what if analysis. The other thing, which is really causality special, is called counterfactual experiment. That is, after you've collected all these things, if you had to ask a question like, if I had not done that, what would have happened? Think about it, how hard it is to do when you have actually made measurements. Think in a social or a biomedical experiment case. You've collected all these data. If I had not given him aspirin, would his headache have been cured? How do you ever answer that? Those are the counterfactuals. It didn't happen, but say you can ask and answer those counterfactual. So here, again, I couldn't think of really compelling ones. I was simply saying if the RPM sensor failed or some other ones, motor RPM sensor failed, can you use this, the tire RPM sensor as a proxy? Not a great counterfactual, but there are counterfactuals. In my paper, I talk about a bearing failing and then what would happen. So those kind of things can be addressed. So this, I think, would give this group a sense of the value of what it is.
What do you think, Marc? you find any of this relevant for the kind of work that you do?
I think it's really, really interesting. But I have a question actually. So, how does it scale to move from one customer to the other with this? No, or so you need a lot of specific stuff every time that you go to a specific company or industry.
So let's stay with this EV example. So let's say this is a Volkswagen, EV platform, right? So they build the exact same, a million of them, or they would use the same platform for 3 other models, right? So for all of them, it'll be the same DAG, right? The causal graph will be the same. Now, the beauty of this is a self-learning thing. The weights that I talk about, see, this is one of the big problems in IoT. A lot of think about instantiating something, let's say predictive maintenance, and you have 1,000 motors on a plant floor. I used to use that for, I used to deploy this in paper plants, steel mills, the old Saturn, auto factory. Each one, you have to instantiate, you have to set these things, you got to put all this stuff. Here, the paper that talks about, and I'm giving this all away, by the way, the algorithm actually learns. All you need is this, set up the car, as it runs, it learns these things, and then it is set. So the deployment part becomes easy. Now, if you have to do it for a green building HVAC system, of course, the graph is different. But again, with one domain expert, with maybe a group of domain experts, you come up with the graph, and then you put that in, and the estimation algorithm will then start instantiating it. So every instance now is in your library, and you can use that for the predictive maintenance type of aspects on a continuous basis and for the dashboard. And the analysis will be done for, more or less often offline, right? What if analysis? You're not doing it while you're driving, right? So this is for improving the business productivity of Volkswagen or, the distribution site. So that's how it is used.
Okay, so you mentioned discovery. That's where you have the domain experts come in and kind of set up the graph. Is that how we're supposed to look at it? Okay.
So 2 big steps: causal discovery, causal estimation. Causal discovery, fortunately, we can punt it. Well, I think Anthony Bourdain is here, right?
Yeah, he is.
Yeah.
Hey, Rob.
Hey, it's Anthony here. Talk about cooking.
Really? Yeah.
Rob, I've been calling you Anthony Bourdain of IoT.
I like that.
The bad boy.
That.
The
That's
bad
cool.
boy. The bad boy. IoT.
I love it. I love it. How are you doing?
I'm doing great, man.
Good. I'm good. Just lots of meetings.
Yeah. So,
know.
hey, where are you, Rob? Are you still in Arizona? Are you in the
No, I'm
desert?
back.
You're back at home?
Yeah.
Oh, okay. I've never seen that background before. I always see
Because I'm just sitting in a random chair.
Oh, really?
Where is home, Rob?
I'm just out in Duval.
Oh, your neighbor. I'm in Maple Valley now.
Okay, cool.
All these Microsoft guys. Yeah. So PG's been rapping about causal digital twins, and he's stepping us through the process of actually setting these things up. So, but
Excellent.
You missed out on most of it, man.
That's the story of my life.
Yeah, but this is a podcast, so it can be watched later, right?
That's right. I'll watch the video and learn. Yeah. Absolutely.
And Rob, just a special for you. You call me and I'll walk you through this.
Okay, that's cool.
Anytime.
I appreciate it.
Yeah.
That's good.
Yeah.
No problem.
Absolutely.
So apparently these causal digital twins, and we'll have to ask you, PG, why digital twin, but these causal digital twins are geared toward answering the why. Is how you simply think about it, right?
Exactly.
Yeah.
Exactly. Whenever you want to know why, you may not realize it, but you don't need causality. So now we are exposing it and making it clear that yes. So you know where to go look. This is why I just wrote a blog yesterday saying explainable ML. If you don't look at and dig into causality, you'll end up in tears because you won't find an answer. Yeah, you can't find explanation unless you know whys. So there is a way forward. And in the case of digital twin and IoT, it's just my personal preference. People can do wherever, whatever. The algorithms that I have published is applicable in any area. But my personal interest happens to be this. And you said, why digital twin? I have a personal opinion that digital twin is the home of machine learning and AI in IoT. That's where we need it. That's where it comes together. Now, this can, of course, be on the edge, some small part of it. The other part of it, where let's say we do what if analysis and counterfactual experiment, that'll be offline on the cloud. But the EV performance graph that comes up, or knowing, oh, okay, the current is that link is getting hot, that's all in the edge, right? So there is a separation, but I think of it as this resides in a digital twin. It's a convenient way of thinking about it for me.
Oh, okay. Yeah, no, I mean, last week we got into all kinds of weird discussions about digital twins. It's just we're seeing a lot of, let's call it metaphysical overloading of the idea of digital twins, which I thought just kind of confused the issue. The way, I mean, at least I like to think of digital twins is that it's solving a certain type of problem, and a lot of what you're talking about are the analytics that you might apply to a quote unquote digital twin.
Right.
Because then we've seen some diagrams where literally the digital twin becomes like everything. It's like, okay, then what are we talking about?
Yeah, it's a suitcase.
That's where and that's where things get kind of iffy, But I can totally appreciate the form of analytics that you're talking about here in terms of analyzing real-time performance and then being able to take data that's streaming off of an asset, do sort of this multivariate analysis, and then stitching together these causal. Are you call them causal graphs, or what do you call them?
Yeah, causal graphs are those DAGs, the directed acyclic graph.
Yeah.
Causal graphs. There are two more things that are specific to this causal digital twin. One is, at least majority of the time, today's IoT applications, such as predictive maintenance, etc., is asset per asset. They look at an asset. This one is about connected set of assets. So you're going from that maintenance mindset. Like I said, maintenance is a hard sell. I did that 20 years ago at Rockwell. Boy, that's a very hard sell to the customers. But if you say it'll improve your production or higher quality, so you can charge higher, cha-ching, the people start buying.
Yeah.
So we got to move into that domain. So here it is right for that. This is for a set of connected assets and their dynamics. So connected assets, dynamics. When you think about what Preet Banerjee does at ANSYS and others, huge simulation digital twins, it's all about structure, right? It's about heat and stress and static things. So static things are useful. It's good in the design and stuff. But when it's operational, it is the dynamics of it. How are they interconnected? That EV example, how is the current being drawn and how is the RPM and torque being related? It is the dynamics of it that affects the current draw, not just the statics of the tire diameter and so on. They have a role to play, but then as they are operational, it is the dynamics that comes into play. So this one specifically addresses over and beyond current methodologies, the dynamics of connected assets. Of course, you can do all predictive analytics on standalone assets, of course, but that's the real differentiation of causal digital twins. Now, if I may, Leonard, there is one slide that I wanted to show, and if you would let me.
Okay.
This is, I know this is about the time you may be wrapping up. So this is an offer that I have for all of you and for other people that you know. So in my career, I've reached a stage where I'm giving everything away. I'm giving a bit of my money away to causes, but also the things I know. So can you see a slide which says my offer?
Oh, yeah.
Yeah, everything is in public domain. I'm willing to give away the code. I'm actually willing to handhold them, or people who are interested in POCs. No compensation, nothing required. I just want to see this proliferated because I believe it is so important. Then, of course, if you want to take it productized, I'm sure you can patent it and companies can make it their own. But these first two stages, and I'm particularly interested in a few of these domains: manufacturing, automotive, and grid buildings. It's kind of very fashionable today. So please let any of your colleagues and cohorts know that this offer is on the table, cost them nothing, just a real commitment. And of course, you have access to this data. So it will probably have to be companies working in manufacturing, automotive, utilities, or green buildings.
Wow, that's very kind of you.
Hey, my little bit, Rob.
Yeah, Rob does a bit of this too. So
Give.
Right? Yeah.
Yeah.
Any thoughts, man? Rob, Mr. Anthony Bourdain of IoT.
I'm just so flattered to be the Anthony Bourdain of IoT because I'm a bad boy. That's awesome.
There you go.
I miss that guy. He is great.
I hope you can cook like him. No,
I try. I put stuff on Instagram. I cook. I'm about to make a cookbook of foods that are bad for you.
Oh, okay. So don't cook this.
Nice.
I see. Don't cook this.
Good.
I think I'm up to 4 or 5 different variations of queso dip. So good stuff.
Yeah.
It may not be good for you, but it tastes good.
Yeah. Well, usually I'll say that I'm running out of coffee, but I'm like faded, man. I had the second shot of the Moderna shot.
Oh, tell me.
And it beat me up last night.
When did you get the shot?
I got it at 9 a.m. Yesterday. And
okay.
Starting around 9 p.m., it just started kicking my ass.
Oh.
Yeah. So sweating at night. So
yeah.
Faded. So I'm ready to.
Yeah, I get my second Moderna shot next Wednesday. I get 2 in the afternoon.
Well, maybe you'll be like PG and it won't affect you at all.
Nothing.
Oh, that's good. I'm glad to hear that, PG.
Yeah, it's just random. It's just each body reacts differently. I had no reaction.
Wow,
that's awesome.
Yeah,
good for you. Yeah. That's great.
Yeah, that's what you'll experience.
So, Leonard, I have a question for you, Leonard, and actually for each of you. Can we go around and hear from you what you could possibly do to proliferate this and take my offer to people around you? Let me just hear what your thoughts are.
Yeah, that's a good question. I mean, I think for me, it all really just depends on the problem, the degree of the problem, and the sort of the maturity of IoT solution that's been implemented, and that people are, like vendors are offering. So it's hard to say. I mean, a lot of this stuff to me seems pretty advanced. If you're looking at the maturity curve of an IoT solution, you're pretty much looking at a mature environment and mature practices as well as capabilities. So this is all kind of new to me. So I'd have to think about it, and we'll have to see if we share it around and if there's any interest,
Rob, any thoughts?
Yeah, well, certainly it starts with a show here. And then, I like to write. I write a lot of articles about digital twins and stuff. And I have a digital twin kind of testbed runtime platform here at home in my office. And so what's fun is to try things out. And so I think maybe a good idea would be to take one of your ideas there and try it out, and then write about it and talk about it and say, hey, look, it works. Look at this cool thing we got to work. So I think that's probably a good first step.
Rob, I like that. The testing I've done it with is this rather famous NASA bearing setup. So lots of people in this domain know that. But something which is real now, hands-on, that'll be an awesome thing. So love to talk to you about this offline.
Absolutely. Yeah.
Marc, any thoughts on what you can do with this now that you know this?
Yeah, it's a good question. I don't know what to say after Leonard and Rob, but yeah, I think let's see what let's publish this video and let's see what the community says, right? Let's try to incentivize them to test it, to send you messages, and let's see what people can do or want to do with this. I think this is really interesting.
Thank you. AGK, I know you see Silicon Valley, a lot of startups. Do you see anyone thinking about a causality in your Thai family?
Yeah. So what I would like, this is my suggestion, right? Having listened to your, talk here, my suggestion would be for each of that vertical that you've suggested in your offer, if you could think of, I would even, like a POC story or a user story, demo story or something like that, if you write a small abstract for it, and then work with some of the leaders in those domain, right? Either their research labs or, or even startups, for example. Like now, I'm particularly interested when you talked about automotive, because our company has got this autonomous vehicle and automotive group. And, I could talk to our pure research guys there and see if there is something that we could do, especially, because you talked about a little bit about ANSYS work they're doing on simulator. Because right now, for example, for the autonomous vehicles to be, viable, right? You need to have a lot of simulation kind of stuff, right? Because, you need to train your models all the time. And can't be, going and trying this out on the road every time you change it, right? So you got to. So is there anything you can do there where you can knobs and ask, hey, why am I, like for example, I drive. I'm not about others, but I certainly have a Tesla, and I'm driving around, and it's annoying to my wife though. But I try to put it on autopilot as much as possible, right? So see under what circumstances it keeps disengaging. Yeah. And I'm assuming that whenever it disengages, it's, Musk companies collecting the data, and then hopefully they'll improve it, right? That's the idea behind it. Of course, they have diehard alpha, drivers and all that stuff. But, I'm not in any signed up program or anything like that. But simulation is an area that I could think of, trying this out. So we have an initiative in our company, and I'd like to work with. I'm just giving you one example, right? That's what the thought came to my mind as I was listening to you. But you could look at every other thing, manufacturing the same way, right? Somebody who's doing it time and again, like so understanding that, and then trying it out so that people see the benefit, right? Ultimately, success breeds success, right? Even if it's a little success, you've done a big dent. That's the way I look at it.
Yeah, and I agree. Sorry, Rob. That the next thing is POCs. That's why I've put this as the offer. Then it'll take a life of its own. People want to see it actually working. And Leonard, you're also right in the sense that this is not where the puck is. This is where the puck is going to be. But startups want to do where the puck is now because that's where the money is. They can't wait for where it's going to go. It's too long, they'll be dead. So it really is. I think AGK's offer is amazing. It is people like this in the domain. We have a very small group, but I think you all are so well connected. So you may know people in manufacturing and green buildings, and I know IBM is very interested in doing this for utilities. So I'm not going around selling this. I'm more of sitting here ready to give it away and also handhold them through the POCs. So AGK, I would be more than delighted to try it out on your Tesla. We'll go put some sensors on it, maybe.
No, I don't know.
Yeah.
Okay.
There's enough of it already on that.
Good stuff.
I think Teslas need eyelashes.
What?
That's
Nice.
They need eyelashes. That's why they keep disengaging. Bugs, bugs on the camera lenses. These can't drive blind, right?
That's kind of like when we talked about sensors going bad and who's watching the Watchmen.
Yes.
Right. I mean, it's. Anyways, I'm out of gas. But and PG, thank you so much for joining us. AGK, thank you for joining us and sharing at the very end. And we appreciate that very much. And for our listeners, thanks for joining us. And we will be back next week with another episode on another IoT topic that Rob is going to just go nuts over, right? You're going to go ballistic, brother.
We're going to cook stuff like Anthony Bourdain. That's what we're going to do.
Okay. All right, gentlemen.
All right.
We'll see you
Bye,
next
everybody.
week.
Thank you.
Bye.
AGK.
Thank you so much.
Thanks for the opportunity.
Bye.